All right, in this segment we've added another category for the solutions chapter, and that is making a solution. We'll start with making a solution from a solid. So the goal is to prepare a 0.1 molar solution of sodium hydroxide, starting with solid sodium hydroxide, and we want the total volume to be 500 milliliters. Now that volume that we need is going to dictate the size of the volumetric flask that we need. Okay, so the volumetric flask we have is designed for 500 milliliters, and so if we fill up to the line that's present on there, that'll give us 500 plus or minus 0.1 milliliters of solution. So what we need to do first is figure out the mass of sodium hydroxide we would need to measure out. So we would take our 500 milliliters of solution that we want to prepare, and the ratio of volume to moles is for every 1,000 milliliters, which is of course 1 liter. We want 0.1 moles of the sodium hydroxide. We can't count out moles, but we can measure grams, and so we would convert moles of sodium hydroxide to grams of sodium hydroxide. And if we do this calculation, we end up with 2.00 grams of the sodium hydroxide required. All right, so we're going to get out our sodium hydroxide in our balance. All right, and we'll measure out 2.00 grams of NaOH. Okay, so that's in a solid form. We never want to add solids directly to the volumetric flask, so we're going to take that 2.00 grams of sodium hydroxide. We're going to first dissolve that in some water. So we're going to put that into a beaker, and we're going to add distilled water to that. Obviously something less than 500 milliliters to get all that solid to dissolve first. The reason for this is that we do not want to put solids into the volumetric flask in case they can't dissolve. If they don't dissolve, it's nearly impossible to remove all that solid from the volumetric flask. All right, so once we get all that to dissolve in there, then we're going to take that solution now, and we're going to add it to our volumetric flask. We're then going to add some more distilled water to that original beaker, swirl it around, and combine that in the volumetric flask. And what we're trying to do is get as much of the sodium hydroxide that may have been in that beaker into the volumetric flask. So we may even do that a couple of times, spray the walls of the beaker off and dump it into the volumetric flask. And then the very last step that we'll do is we'll take that distilled water and we'll add it to the volumetric flask up to the designated line that indicates 500 milliliters plus or minus 0.1 milliliters. So we would get a very precise concentration for our solution in this way. The other way that we may make a solution is by diluting an already existing solution. So in the example here, the object is to create 100 milliliters of a 0.1 molar solution of sodium chromate. Now a little lazy with our significant figures. We should probably have 0.100 molar sodium chromate, but this will be okay for now. So we know the final volume that we're looking for. We know the final molarity, and we know the initial molarity that we've got. So what we're really doing here is a dilution problem. But what we need to find out is the volume of that initial solution, that 6 molar sodium chromate solution that we need. So we're going to solve for volume 1, and our dilution formula would be volume 1 would be equal molarity 2, volume 2 divided by molarity 1, or the volume we need of that first molar solution can be determined this way. So our molarity that we're shooting for is a 0.100 molar solution. We would like to have 100 milliliters of that solution. And the molarity that we're diluting is a 6.0 molar solution to start with. So the volume of that solution that we're going to need is 1.67 milliliters. Now notice that we don't need to convert to liters for our volume here. What this is going to give us, that the molarity units are going to cancel out, so it's going to give us the milliliters that we need to measure to add to our flask. Given that we are looking for a 100 milliliter solution, we would use a 100 milliliter volumetric flask. To measure the 1.67 milliliters, so it's a fairly small volume, but we're going to use a volumetric pipette. And these are graduated to where we could get a volume of 1.67 milliliters. We would add that to the volumetric flask, and then we need our water back again. So here's our water. Once we added the 1.67 milliliters, we could then fill up to our designated line with the distilled water to get our 100 milliliters of 9.1 molar solution. So a dilution problem is a little bit simpler, a little less that you have to do in comparison to our starting from a solid. A little bit more involved there. But these are the two ways that you would make a solution in the lab.